Okay, I want to go over the complementary angle results just using Geometry Sketchpad, and what I've constructed here is the unit circle in green. I've got this point here C, um, which is the point on the unit circle at the moment that is representing angle ABC, which is 17.56. You can see as I move C around to make ABC change, 25.47. So does FBG, which is that angle there. So all these angles, you see these ones that are made with the y-axis, equal to this angle here that we're making with the x-axis. So if we call this angle here theta, then this angle here is theta, so is this angle here, so is this angle, and so is this angle. So we've created these angles. If that's theta, then this one around here, ABJ, is 90 minus theta. This angle around here, ABG, is 90 plus theta. The angle right around here to I is 270, or 3 pi on 2 minus theta. And finally, all the way around to H, ABH, 3 pi on 2 plus theta. Now, the really interesting thing here is the coordinates 0.95, 0.3 that are set here by C, the point C. They are, look at that, these are all 0.95 and 0.3s, but in different places. Now what happens is that 0.3 is the x coordinate on each of these other points, and 0.95 is the y coordinate, so they switch immediately. So that means that here, if we ever look at cos theta, because this is theta, remember, cos theta is equal to sine, because there's a 0.95, 90 minus theta. But it's also equal to sine 90 plus theta. That doesn't change it, you see, 90 plus theta. And it's also equal to, well, no, it's not, it's minus now, minus sine 270 minus theta and minus sine 270 plus theta, because those are now negative. And if we look at sine theta here at 0.3, then that becomes cos theta here, or 90 minus theta, minus cos 90 plus theta, minus cos 270 minus theta, and positive cos 270 plus theta. So what I'm going to do in a moment is flip back to another screen. We'll call these points A and B, because they're just held. This the 0.3 and 0.95 switch, and then depending on which quadrant they're in, their signs change accordingly. But we have a relationship that holds. Okay, so let's just get rid of that a moment. So what we've got, and we've looked at these, we looked at them in different sort of ways in my previous screencast. We looked at the 90 minus theta results using this little triangle. Then I tried to bring in this stuff 90 plus theta, but then when it got to 270, it got a bit confusing, didn't it? So if we now just relate it all back to the points A and B, it should hopefully clarify the whole thing up for us. So this is what we just saw. The reason I gave it to you on that nice circle here was that the points are all calculated for us, and the really powerful thing is that we can see whatever we move this to, it's now 0.87, 0.5, they just switch there, and so the numerical values just hold. So if we represent that now statically on my unit circle here, if I just create a little, if I just create a radius here, call that theta, and now let's have this as the point AB. Okay, now what we're saying here is if we just pop a little, if we make that theta, we make that theta, that theta, and that theta, then all that happens with these, this becomes BA, this becomes minus BA, this point down here becomes minus B minus A, and this point becomes, what's happened here? It's gone back to positive B minus A. So what we can get from all that is that sine theta, which is B, is equal to cos, now this angle in here is 90 minus theta, isn't it? Because that's all the way around to 90. Take away theta, it's 90 minus theta. So around to here, that angle there is 90 minus theta. This one here is 90 plus theta, or we can write it as pi on 2, obviously. Pi on 2, interchangeable. This angle down here, this is 270, or 3 pi on 2 minus theta. And this one here is 3 pi on 2, being 270, plus theta. Alright, that's 270 degrees minus theta, or I can write it as 270 degrees plus theta. Okay, so sine theta, which is B, is equal to this one here, which is cos 90 minus theta. Okay, so there's that result. And we can also say that cos theta, which is A, is equal to sine 90 minus theta. So we've got the 90 minus theta results done. Now let's have a look at the 90 plus theta results here. So what happens there is cos theta, which is A, matches up with sine 90 plus theta, which is also A. Now let's check for what about sine theta, which is B, goes to cos, or minus cos, sorry, 90 plus theta, because it goes from B to minus B. Okay, so they're the 90 plus results. Take it down here to the 270 minus. What happens? Cos of theta, A goes to, it goes to minus sine 270 minus theta. And sine theta, which is B, goes to minus cos 270 minus theta. Brilliant, isn't it? And finally, cos theta will do the 270 pluses. Cos theta, which is A, becomes minus sine 270 plus. And sine theta, which is B, goes straight to cos 270 plus theta. Okay, so if we can get everything from this, just this little circle here. So if we have a look at, let's have a look at a couple of the questions. I just want to look at so a few of these questions here from exercise 16K, which I've left you for homework. Just looking at, say, question 1b, which was, 1b, which is sine pi on 2 being our 90 plus alpha. Now sine pi on 2 plus alpha, which is A, is the same as cos alpha. And cos alpha we've got is 0.6. So we've got that in. Okay, now for tan 90 minus theta, which is F, we have okay, so what we're after is tan of this angle here, which is, as we know, sine divided by cos, so A divided by B. What we know is tan theta equals 0.7. That's B divided by A. So what we want is the reciprocal of tan theta. So I'll just repeat that. We're after A on B because we want tan of this, tan of 90 minus theta. We're given tan theta is 0.7, so that means B over A is 0.7. We want A over B, so we want the reciprocal of 0.7. So 1 over 0.7 is 10 over 7. So that gets through F. Let's just have a look at maybe I. Sine of 90 plus, let's have a look at sine, so not 90, 3 pi on 2, 270 plus alpha. Okay, so sine of 270 plus alpha, let's go to that. 270 plus alpha is this one here, so we're after minus A, which is the negative of cos alpha. And minus cos alpha is minus 0.6. Let's have a look at J as well. Let's look at cos of 3 pi over 2 minus x. Okay, 3 pi minus 2 minus x, so that's this here. Cos of it is minus b, so that's the negative of the sine that we started with, so that's equal to minus sine x, and sine x is 0.3, so that's minus 0.3. Okay, so that's quite tricky stuff, but hopefully that helps. I'll just do one question 2. Now I wanted to do 2AB and then 3, 4, 5. But if we just maybe do... Okay, so I'm just doing 2C, you're going to do A and B. I'm just going to show you, perhaps with the help of this example, you might be able to proceed. Without it. But here we've got cos theta equals sine pi on 12, and theta's in the first quadrant between 0 and 90. What we're using here is the fact that there's this complementary result where cos of 20 will equal sine 70. These angles will be equal. This equation will be equal. This will be solved, when theta and pi on 12 sum to 90. So theta plus pi on 12 must equal pi over 2. So theta is pi over 2 minus pi over 12, which is 6 pi over 12 minus pi over 12. So we get 5 pi over 12. Essentially, what we've got there is, so cos 5 pi over 12 is equal to sine pi over 12, because those two, pi over 12 and 5 pi over 12, sum to pi over 2, which is 90 degrees. So we'll do the same with D. D says, given again that theta is between 0 and 90, or pi and 2, sine theta is equal to cos 3 pi over 7. So these are going to be equal when theta plus 3 pi over 7 is equal to pi over 2. So again, we'll do some fraction work on this. Theta on 2 minus 3 pi on 7, pi on 2, sorry. So that's 7 pi minus 6 pi over 14. So pi over 14 is theta. So pi over 14 plus 3 pi over 7, which is 6 pi over 14. If you think about it, you add those two together, you get pi over 2. So there's how to do C and D. You basically just need to sum them to 90. And then question 3, 4, and 5, using the little triangles as we went through here, and again on the board today with some examples. That'll help you through 3, 4, and 5. Okay, I'll see you in class tomorrow.